Above the Dutch lowlands on that mid-September day in 1944, more than 14,000 feet separated the paratroopers from the earth below. Operation Market Garden had commenced, and what unfolded represented the single largest airborne deployment military history had witnessed to that point. American fighters circled overhead, their wings laden with explosive payload that would have seemed utterly absurd just a year and a half prior. German interceptor pilots climbing to meet them encountered something their command structure had never anticipated. These bulbous Republic aircraft, the same machines Luftwaffe intelligence had categorized as overweight and unsuitable for serious fighter work, now hauled 2,500 pounds of ordnance into combat. That figure represented more than 60% of what a flying fortress typically carried on extended bombing runs over enemy territory, a rough equivalent to half the heavy bomber's working load. The transformation that had occurred defied everything German tactical planners understood about aerial warfare doctrine. Here flew single-seat aircraft powered by single engines, yet they possessed capability to battle their way through defensive screens, obliterate ground targets with bomber-level destructive force, then fight their way back to friendly airspace. What emerged from American factories had revolutionized not merely tactical implementation, but fundamental concepts of how air power functioned. The Wehrmacht's collapse accelerated dramatically, and military aviation would never return to its previous rigid categorizations. German strategists never grasped that American industrial philosophy had produced something beyond their experience, neither pure fighter nor dedicated bomber, but rather a universal combat platform capable of executing any mission profile with remarkable lethality. When Republic's P-47 Thunderbolt first engaged enemy forces in April of 1943, Luftwaffe analysts reviewing initial contact reports found their preconceptions thoroughly validated. American design philosophy seemed to emphasize brute force over refined engineering. The 4th Fighter Group flew the type's inaugural official sortie on the 8th day of April, and German technical assessment teams studying intelligence photographs and combat reports reached conclusions that surprised nobody. Raw specifications told a discouraging story from any conventional perspective. Empty weight exceeded 10,000 pounds, fully double what a Messerschmitt Bf-109G registered on the scales. Power came from an absolutely massive Pratt & Whitney radial, the R2800 Double Wasp, with its 18 cylinders arranged in twin rows, initially generating 2,000 horsepower. Later production models would push that figure to 2,300, eventually reaching 2,800 horsepower in final variants. Yet all that power had to accelerate an airframe that appeared designed by engineers who had never considered streamlining as a worthwhile objective. Early combat encounters seemed to confirm German technical superiority across multiple parameters. Combat radius barely exceeded 125 miles, severely restricting escort effectiveness for bomber formations. Climb performance lagged behind German interceptors, and when engagements devolved into turning fights at medium altitude, both the Focke-Wulf 190 and Messerschmitt 109 demonstrated clear advantages. Luftwaffe tactical development units quickly formalized exploitation methods, forcing the heavy American machines into horizontal maneuvering or vertical climbs, where mass became liability rather than asset. What German evaluation teams completely failed to recognize was that they were analyzing an infant design, an aircraft whose full potential would require another 12 months to properly manifest. That robust construction they criticized as excessive weight served purposes they never considered. Steel tubing formed the basic structure, armor plating protected vital components and pilot, and the entire assemblage could absorb punishment that would disintegrate lighter airframes. More significantly, those wing pylons originally intended for external fuel tanks had been engineered to carry up to 2,500 pounds of external stores. Most contemporary fighter designs would have suffered catastrophic structural failure attempting such loads. Evolution began not through grand strategic vision, but through pragmatic field adaptation. As 1943 progressed through summer into autumn, Escort pilots returning from bomber protection missions began attacking targets of opportunity during their return flights. Railway locomotives, truck convoys, fuel storage facilities all proved vulnerable to strafing attacks. Results came back immediately promising. 8 Browning M250 caliber machine guns, each weapon cycling 800 rounds per minute, could collectively deliver 12.7 pounds of lead downrange every second. Locomotive boilers exploded, truck convoys disintegrated, entire supply columns ceased to exist under that concentrated firepower. Official bomb-carrying modifications arrived in November of 1943. Engineering teams installed shackles rated for 500-pound bombs on both belly and wing hardpoints. The 25th day of November saw the 62nd Fighter Squadron execute the first authorized bombing sortie, hitting a Luftwaffe airfield at Saint-Omer in occupied France. 8 Thunderbolts, each aircraft carrying 2 250-pound bombs, successfully eliminated 2 hangars and damaged 5 aircraft caught on the ground. The winter months spanning late 1943 into early 1944 witnessed Republic Aviation's Engineering Division working in concert with Army Air Force's technical services to dramatically accelerate the transformation process. Wing spars received reinforcement to handle asymmetric loading scenarios when only partial ordnance released. New electrical systems controlled bomb release mechanisms that needed to function reliably, whether the aircraft operated at 30,000 feet or skimmed treetops. Specialized gun sights emerged, including the K-14 computing sight that could calculate proper bombing angles for both dive attacks and glide approaches. By the time winter transitioned into spring 1944, modifications had progressed far beyond simple rack installation. The M8 rocket, 4.5 inches in diameter, packed destructive power equivalent to a 105mm artillery shell. A single Thunderbolt could depart with 10 rockets plus 2,000-pound bombs, delivering more explosive force than many twin-engine bombers carried during early war operations. The 6th day of June 1944 represented the moment Luftwaffe Command fully comprehended what American fighters had become. During that single 24-hour period, P-47 units flew 1,985 individual sorties, dropping 525 metric tons of explosives while expending 135,000 rounds of 50 caliber ammunition. Confirmed destruction tallies included 86 locomotives, 507 motor vehicles, 38 artillery positions, and 17 fuel dumps. The aircraft German intelligence had classified as a mediocre high-altitude interceptor had transformed into tactical air power's primary workhorse. Gunther Rall, whose 275 confirmed victories placed him among history's highest-scoring fighter pilots, engaged P-47 formations repeatedly throughout 1944. Speaking with HistoryNet nearly 50 years later in 1996, he recalled specific performance characteristics. The Thunderbolt, which shot him down, possessed tremendous diving speed reaching 1,400 km per hour, while the Bf-109 remained limited to 1,000. He learned this differential quickly when American fighters pursued him, leaving no defensive option. On the 12th of May in 1944, P-47s from the 56th Fighter Group shot Rall down, the engagement costing him his left thumb. His damaged flying glove eventually found display at the National Air and Space Museum. After hostilities ceased, Rall spent approximately 300 hours evaluating captured American aircraft at the German Fighter Leaders School, including extensive time in P-47s. The capability to instantly transition from ground attack configuration to pure fighter created impossible tactical problems for Luftwaffe planners. German interceptors vectored against what appeared to be vulnerable bomb-laden attackers suddenly found themselves engaging aircraft that had jettisoned external stores and reverted to fighter role, possessing superior firepower and astonishing damage tolerance. Statistical analysis of payload capacity created mathematical impossibilities for German logistics networks. A standard P-47D-25 could depart carrying various ordnance combinations, either 2,000-pound bombs, 3 500-pound bombs, or mixed loads combining bombs and rockets totaling 2,500 pounds. This represented approximately 62.5% of a B-17's typical 4,000-pound operational load on extended-range missions, hence the reasonable characterization as roughly half a Flying Fortress bomb load. 16 aircraft forming a standard squadron could deliver 32,000 pounds of explosives, equivalent to 8 heavy bombers operating at typical combat loads. Unlike strategic bombers flying from England perhaps twice weekly, P-47s could fly 3 full missions daily from forward airstrips. A single fighter squadron could theoretically deliver more tonnage during one day than a heavy bomber squadron managed across an entire week. Efficiency differentials became stark under analysis. One P-47 carrying 2 500-pound bombs required 1 pilot and minimal ground crew support. One B-17 carrying 4,000 pounds of bombs required 10 aircrew plus specialized ground maintenance teams. The fighter-bomber delivered significant destructive capability with fractional manpower investment. August 1944 brought the most devastating demonstration of fighter-bomber effectiveness during the Falaise Pocket encirclement. As German forces attempted escape between the 12th and 21st of August, they faced continuous attack from P-47 units operating in shifts from sunrise to sunset. Authenticated kill claims, verified through ground reconnaissance teams, included specific daily tallies. The 13th saw 112 tanks confirmed destroyed. The 14th brought 287 motor vehicles eliminated. The 15th recorded 42 locomotives demolished. The 16th tallied 89 horse-drawn vehicles wrecked. 9th Air Force P-47 groups operated relay systems with fresh squadrons arriving as others departed for rearmament and refueling. This maintained unrelenting pressure on any German forces attempting daylight movement. Post-battle analysis determined approximately 1/3 of all German vehicles destroyed in the pocket fell victim to air attack. The 362nd Fighter Group pioneered systematic rocket attacks against armoured targets. Their after-action documentation detailed the technique precisely. Diving from 5,000 feet at 30-degree angles, releasing rockets at 1,500 feet altitude, they achieved direct hits on 30 to 40% of launches. This far exceeded artillery accuracy rates against similar targets. The December 1944 Battle of the Bulge demonstrated P-47 evolution into all-weather fighter bomber. Despite freezing fog and snow grounding most aircraft, P-47s equipped with British-developed rocket rails and improved instrumentation continued operations. When weather briefly cleared on the 23rd of December, P-47 units flew 647 sorties, claiming over 400 vehicles destroyed. Statistics from December 23rd through the 27th revealed comprehensive impact. 201 German tanks confirmed destroyed, 1,930 motor vehicles eliminated, 953 horse-drawn vehicles wrecked, 89 locomotives demolished, 512 rail cars destroyed, 47 bridges damaged or eliminated. January 1945 revealed additional capability in precision bridge busting using 1,000-pound bombs. The 56th Fighter Group developed techniques for destroying Rhine bridges that had survived heavy bomber attacks. 8 P-47s could deliver bombs with 50-foot accuracy in 60-degree dives, far exceeding the precision of high-altitude heavy bombers that considered themselves fortunate achieving 1,000-foot accuracy. The deployment of Me-262 jet fighters in early 1945 should have revolutionized air combat. With 100-mile-per-hour speed advantages over P-47s, the jets appeared immune to conventional interception. Yet P-47 evolution into fighter-bomber role created unexpected vulnerabilities for jet operations. Me-262S required long concrete runways and consumed fuel at prodigious rates. Their bases became primary targets for P-47 fighter-bomber formations. On the 21st of March 1945, P-47s from the 365th Fighter Group caught JG-7's Me-262s during takeoff operations from Leifheim Airfield. Jets accelerating down the runway could neither maneuver nor achieve the speed necessary for escape. 8 Me-262s were destroyed within 5 minutes, exceeding Luftwaffe weekly production capacity. March 1945's Operation Clarion saw systematic destruction of German transportation infrastructure by fighter bombers. P-47S received sector assignments with orders to destroy anything currently moving or potentially capable of movement. The 22nd of March alone saw P-47 units claiming 89 locomotives destroyed, 1,026 rail cars demolished, 155 motor vehicles eliminated, 17 bridges dropped, and 93 rail cuts where tracks were severed. Continuous innovation supported P-47 transformation. The P-47 D-25 variant, introduced mid-1944, featured reinforced wings stressed for 3,000-pound external loads, universal bomb shackles accepting both British and American ordnance types, zero-length rocket launchers reducing aerodynamic drag, improved oil cooling systems for extended low-altitude operations, paddle blade propellers improving acceleration characteristics, water injection systems boosting power output to 2,800 horsepower, and the K-14 computing gun sight enabling accurate bombing. Republic Aviation's facilities at Farmingdale and Evansville demonstrated remarkable production flexibility. Peak output reached 35 complete aircraft daily, with 28 major variants produced alongside 430 distinct field modification kits developed. Manufacturing plants maintained continuous production across 48 consecutive months without halting for major redesign, a feat unmatched by any other fighter manufacturer globally. Transforming P-47 pilots from fighter specialists to multi-role combat aviators required revolutionary training approaches. Army Air Forces established programs requiring 200 flight hours minimum before combat deployment, including 50 practice bombing runs, 20 rocket firing passes, 100 strafing runs, 40 hours of instrument flying, and 30 hours of formation flying. This comprehensive preparation contrasted sharply with late-war Luftwaffe pilot training, which had declined to merely 110 flight hours before combat, with zero fighter bomber training provided to fighter pilots. American pilots demonstrated competence across diverse mission profiles, including high-altitude escort, medium-altitude combat, low-level navigation, dive bombing, skip bombing, glide bombing, rocket firing, napalm delivery, and ground strafing, transitioning between roles as individual missions demanded. February 1945 saw napalm bomb introduction carried by P-47s. 150-gallon drop tanks filled with jellied gasoline created weapons capable of incinerating entire city blocks or fortified forest positions. The 362nd Fighter Group first employed napalm operationally on the 14th of February 1945 against a Wehrmacht supply depot hidden within Reichswald Forest. 8 P-47s, each carrying one napalm bomb, created firestorm visible from 20 miles distance, destroying 3 acres of supplies within minutes. The period from March through May 1945 witnessed P-47 development reaching its evolutionary peak. The P-47M variant, capable of 470 miles per hour, entered service with performance matching early jet aircraft. The P-47N, designed for Pacific operations, demonstrated 2,350-mile range while carrying bombs. But tactical employment truly revolutionized warfare concepts. P-47 S operated as forward air controllers directing other aircraft, artillery spotters for ground forces, photo reconnaissance platforms, communication relays, psychological warfare platforms dropping leaflets, and emergency supply deliverers to surrounded units. The same aircraft type could execute 6 different mission categories during a single operational day. European theatre combat record from 1943 through 1945 stands among aviation history's most successful. Total sorties flown reached 746,000. Loss rate per sortie measured 0.7%. Air-to-air kill ratio achieved 4.6 to 1. Ordnance delivered included 132,000 tons of bombs dropped, 135,000 rockets fired, and 119 million .50 caliber rounds expended. Confirmed destruction across the European theatre encompassed 39,116 enemy aircraft in air combat, 32,002 enemy aircraft destroyed on the ground, 9,000 locomotives, 86,000 railway cars, 68,000 motor vehicles, 6,000 armoured vehicles, and 60,000 horse-drawn vehicles. P-47 evolution fundamentally altered military strategy concepts. Pre-war doctrine rigidly separated strategic and tactical air power applications. Heavy bombers addressed strategic targets, fighters achieved air superiority, attack aircraft provided ground support. The P-47 merged these distinct roles, achieving strategic effects through tactical means. Transportation infrastructure destruction by P-47 units accomplished what years of strategic bombing struggled to achieve. By April 1945, German forces could not move during daylight hours. Supply lines ceased functioning. Reinforcements could not reach frontline units. Tactical operations had achieved strategic effects through sheer accumulated impact. Strategic bombing survey analysis revealed that fighter-bomber operations, primarily executed by P-47 units, reduced German rail traffic by 75% in forward areas by March 1945. This transportation paralysis contributed more substantially to German defeat than industrial target destruction by heavy bombers. P-47 success forced fundamental doctrinal changes across military aviation. The United States Air Force's first doctrine manual, published in 1947, stated that artificial distinction between fighter and attack aircraft had been rendered obsolete. All fighters must possess ground attack capability. All attack aircraft must possess self-defense capability. This represented complete reversal of pre-war thinking. The 1935 Army Air Corps Manual had stated that pursuit aviation's sole purpose was achieving air superiority through aerial combat, with diversion to other roles weakening this primary mission. The P-47 proved that mission flexibility multiplied combat power exponentially. A fighter capable only of air combat held half the value of one capable of both fighting and bombing. This lesson shaped every subsequent American fighter design from that point forward. The concept proved so revolutionary that it shaped post-war aircraft design globally. When Korean conflict erupted in 1950, P-47 direct descendants, including F-84 Thunderjets and F-86 Sabres, configured as fighter bombers, dominated tactical air warfare. Multi-role fighter concepts pioneered by the P-47 became fundamental to modern air combat doctrine. Republic Aviation's achievement represented American industrial capability at its peak. Company founder Alexander Kartveli had designed the aircraft with exceptional strength margins built in from initial conception. Army Air Forces requested a 6G-capable aircraft. Kartveli built one stressed for 12 Gs. They wanted 500-pound bomb capability. He provided structure for 2,000-pound loads. P-47. Departing Republic plants in 1945 incorporated hundreds of improvements derived from combat experience, yet production never stopped for major redesign programs. Production statistics reveal the industrial miracle achieved. 48 months of continuous production delivered 15,683 complete aircraft across 28 major variants, with 430 field modification kits developed. Peak production reached 35 aircraft daily from 2 plants operating simultaneously, while costs reduced 27%, despite capability increases. The fighter-bomber concept influenced every subsequent combat aircraft design. Direct descendants included the F-84 Thunderjet, representing jet-powered continuation of P-47 concepts, the A-10 Thunderbolt II, named explicitly after the P-47 carrying ground attack mission forward, and the F-105 Thunderchief, extending P-47 philosophy as strategic fighter bomber. Conceptual inheritors included the F-4 Phantom II, with multi-role capability central to design philosophy. Core principles emerged clearly. Build strong, build adaptable. Let operational requirements drive capability evolution. The comprehensive training program developed for P-47 fighter-bomber pilots established standards still followed today. Modern fighter pilots train for air-to-air combat, air-to-ground attack, reconnaissance, and electronic warfare, a multi-role approach pioneered by P-47 squadrons during the 1940s. The 200-hour pre-combat training requirement for P-47 pilots became baseline for post-war air forces globally. Emphasis on instrument flying, formation tactics, and weapons delivery accuracy established professional standards that defined modern military aviation. Luftwaffe veterans' post-war assessments consistently identified P-47 fighter bomber as decisive factor in German defeat. Authenticated testimony from Gunther Rohl, who flew captured P-47s extensively after hostilities ceased, provides crucial insight. In his 1996 HistoryNet interview, he praised the aircraft's comfort, reliability, and versatility, noting particularly that the engine had no oil leaks, unlike German aircraft he had flown throughout the war. Statistical analysis supports veteran testimony comprehensively. By war's end, the Luftwaffe could muster only approximately 100 operational fighters on any given day. This resulted not from lack of aircraft production, but from lack of fuel, operational airfields, and logistics infrastructure destroyed by P-47 operations. The fighter bomber had achieved what strategic bombing could not: complete paralysis of enemy operations. P-47 fighter bomber capability provided extraordinary economic efficiency compared to traditional bombing methods. Cost per metric ton of bombs delivered measured $28,000 for B-17 Flying Fortress, $24,000 for B-24 Liberator, and only $4,200 for P-47 Thunderbolt. Crew losses per 100 tons delivered measured 8.5 aircrew for B-17, 7.2 aircrew for B-24, and 0.9 pilots for P-47. Support requirements per ton delivered measured 47 ground personnel for B-17 compared to 8 ground personnel for P-47. The mathematics proved undeniable. P-47S delivered destruction at 15% the cost and 10% the manpower investment of heavy bombers. The transformation from pure fighter to fighter bomber carrying half a heavy bomber's operational bomb load represents more than tactical evolution. It embodies American military genius for pragmatic adaptation. The Luftwaffe never expected this transformation because it violated their fundamental understanding of specialized military equipment. German military doctrine emphasized perfection within narrow roles. The best fighter, the best bomber, the best attack aircraft. American doctrine, shaped by industrial pragmatism, emphasized adaptability and efficiency. The P-47 proved that in modern warfare, flexibility beats specialization consistently. When Luftwaffe pilots encountered P-47s over Eindhoven on that September 1944 day, they faced not merely an aircraft but a revolution in military thinking. Those heavy, clumsy interceptors they had dismissed during 1943 had become instruments of their destruction, not through superior performance in any single role, but through unprecedented versatility across all roles. The combat record established in European theatre from 1943 through 1945 stands among aviation history's most successful achievements. Aircraft performance parameters included maximum speed of 433 miles per hour for P-47D variants, 470 miles per hour for P-47M variants, combat radius of 450 miles with drop tanks, service ceiling of 43,000 feet, and maximum bomb load of 2,500 pounds. Production excellence encompassed total production of 15,683 aircraft, monthly peak of 1,050 aircraft, cost reduction of 27% across production run, 28 variants produced, and over 430 field modifications developed. Combat effectiveness measured 746,000 sorties flown, loss rate of 0.7% per sortie, kill ratio of 4.6 to 1, 132,000 tons of bombs dropped, and over 224,000 ground targets destroyed. The story of how the Luftwaffe never expected P-47s to carry half a heavy bomber's bomb load illuminates profound truth about military innovation. The Germans, masters of specialized excellence, failed to anticipate that Americans would blur lines between fighter and bomber, creating aircraft that excelled not through perfection in one role, but through competence in all roles. P-47, Thunderbolt evolution from interceptor to fighter bomber, did not just surprise the Luftwaffe, it revolutionized air warfare fundamentally. Every modern combat aircraft flying today incorporates lessons learned from P-47 transformation. The heavy fighter that could not turn with a Messerschmitt became the aircraft that helped turn the tide of global conflict. In final analysis, the 7-ton fighter that Luftwaffe dismissed as too heavy to master became the instrument of their destruction, not through superior performance in any measurable category, but through superior adaptability to changing operational reality. The P-47 proved that in modern warfare, the winner is not who flies the most specialized aircraft, but who adapts fastest to evolving circumstances. The Luftwaffe never expected P-47 Thunderbolts to carry half a heavy bomber's bomb load because such capability violated their fundamental understanding of air warfare principles. That failure of imagination cost them air superiority, operational mobility, and ultimately the entire war. P-47 transformation from fighter to fighter bomber remains history's clearest example of how tactical adaptation can achieve strategic revolution, and how failure to recognize that revolution can doom even the most professional military force to devastating defeat. The lessons learned over those skies above, occupied Europe between 1943 and 1945, continue shaping military aviation doctrine 8 decades later, testament to how completely the humble Thunderbolt revolutionized warfare itself.